Massive object the size of Mars may lurk beyond Pluto, warping the Kuiper belt. Planetary massive object closer. The so-called Planet 9 plane, signaled by warped Kuiper belt, unseen planet the size of Mars may lurk beyond Neptune. Posted by Sherwood Parker Weather, and also we have phys.org article. An unknown, unseen planetary mass may be lurking in the outer reaches of our solar system, according to new research on the orbits of minor planets to be published in the Astronomical Journal. This object would be different from and much closer than the so-called Planet 9, a planet whose existence yet awaits confirmation. In the paper, Kat Volk and Renu Malhotra of the University of Arizona's Lunar and Planetary Laboratory, or LPL, present their compelling evidence of yet-to-be-discovered planetary body with a mass somewhere between that of Mars and Earth. The mysterious mass, the authors show, has given away its presence for now only by controlling the orbital planes of a population of space rocks known as Kuiper Belt objects, or KBOs, in the icy outskirts of our solar system. So we have an unseen planetary mass object signaled by warped Kuiper belt. This is by Daniel Stottel, University of Arizona. It's on phys.org. Yet to be discovered unseen planetary mass object makes its existence known. The unknown unseen planetary mass may lurk in the outer reaches of our solar system, according to the new research. In the paper by Kat Volk and Renu Malhotra of University of Arizona's Lunar Planetary Laboratory, LPL, they present compelling evidence of this yet to be discovered planet, with a mass somewhere between that of Mars and Earth. The mystery mass, the authors show, has given away its presence for now only by controlling the orbital planes of a population of space rocks known as the Kuiper Belt objects in the icy outskirts of our solar system. While most KBOs, debris left over from the formation of our solar system, orbit the Sun with orbital tilts or inclinations that average out to what planetary scientists call the invariable plane of the solar system, the most distant of the Kuiper Belt's objects do not. Their average plane, Volk and Malhotra discovered, is tilted away from the invariable plane by about 8 degrees. So in other words, something unknown is warping the average orbital plane of the outer solar system. It has a gravitational tug on that area of the solar system. Now, they say the most likely explanation for our results is that there is some unseen mass, end quote, says Volk, a postdoctoral fellow at LPL and the lead author of the study. Quote, according to our calculations, something as massive as Mars could be needed to cause the warp that we measured, end quote. The Kuiper Belt lies beyond the orbit of Neptune and extends a few hundred astronomical units, or AUs, with 1 AU representing the distance between Earth and the Sun, 93 million miles. Like its inner solar system cousin, the asteroid belt between Mars and Jupiter, the Kuiper Belt hosts a vast number of minor planets, mostly small icy bodies and precursors of comets, and a few dwarf planets as well. For the study, Volk and Malhotra analyzed the tilt angles of the orbital planes of more than 600 objects in the Kuiper Belt in order to determine the common direction about which these orbital planes all precess. Precession refers to the slow change or the wobble in the orientation of a rotating object. KBOs operating in an analogous way to spinning tops, explains Malhotra, who is a Louis Foucault Marshall Science Research Professor and Regents Professor of Planetary Science at LPL. She says, imagine you have lots and lots of fast spinning tops and you give each one a slight nudge. If you then take a snapshot of them, you'll find that their spin axes will be at different orientations, but on average they will be pointing to the local gravitational field of Earth. We expect each of the KBO's orbital tilt angle to be at different orientations, but on average they will be pointing perpendicular to the plane determined by the Sun and the big planets, end quote. If one were to think of the average orbital plane of objects in the outer solar system as a sheet, it should be quite flat past 50 AU according to Volk. Quote, but going further out from 50 to 80 AU, we find that the average plane actually warps away from the invariable plane, she explains. And she says there is a range of uncertainties for the measured warp, but there is not more than 1 or 2% chance that this warp is merely a statistical fluke of the limited observational sample of KBOs. In other words, the effect is most likely a real signal rather than a statistical fluke. According to the calculations, an object with a mass of Mars orbiting roughly 60 AUs from the Sun on an orbit tilted about 8 degrees to the average plane of the known planets has sufficient gravitational influence to warp the orbital planet, the plane of the distant KBOs, within about 10 AU to either side. The observed distance KBOs are concentrated in a ring about 30 AU wide and would feel the gravity of such a planetary mass object over time, Volk said. So hypothesizing one planetary mass to cause the observed warp is not unreasonable across that distance. This rules out the possibility that the postulated object in this case could be the hypothetical planet 9, whose existence has been suggested based on other observations. That planet is predicted to be much more massive. That would be about 10 Earth masses, and much farther out than 500 to 700 AUs. So this planet is something different. Quote, that is too far away to influence these KBOs, Volk said. It certainly has to be much closer than 100 AUs to substantially affect the KBOs in that range. Because a planet, by definition, has to have cleared its orbit of minor planets such as KBOs, the author refers to hypothetical mass as a planetary mass object. The data also do not rule out the possibility that the warp could result from more than one planetary mass object. So why haven't we found it yet? Most likely, according to Malhotra and Volk, because we have not yet searched the entire sky for distant solar system objects. The most likely place a planetary mass object could be hiding would be in a galactic plane, an area so densely packed with stars that solar system surveys tend to avoid it. Volk said, the chance that we have not found such an object of the right brightness and distance simply because of the limitations of the surveys is estimated to be about 30%. A possible alternative to an unseen object could have ruffled the plane of outer Kuiper belt objects, could be a star that buzzed the solar system in recent history, by astronomical standards that is. A passing star would draw all the spinning tops in one direction, Malhotra said. Once the star is gone, all the KBOs will go back to precessing around their previous plane. That would have required an extremely close passage at about 100 AU, and the warp would be erased within 10 million years, so we don't consider this a likely scenario. Humankind's chance to catch a glimpse of the mysterious object might come fairly soon, once construction of the Large Synoptic Survey telescope is completed. It's run by a consortium that includes the University of Arizona and is scheduled for the first light in a few months, in 2020. The instrument will take unprecedented real-time surveys of the sky night after night. Quote, we expect LSST, this new telescope, to bring the number of observed KBOs from currently about 2,000 to 40,000, Malhotra said. There are a lot more KBOs out there, that's Kuiper belt objects. We just have not seen them yet. Some of them are too far and dim even for LLST to spot, but because the telescope will cover the sky much more comprehensively than current surveys, it should be able to detect this object, if it's out there. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.